projects. In this video, we are going to explain about the project, which is improved cross-search based feature selection and ensemble learning for IoT intrusion detection. Before getting into the execution, first let us understand what is this project about. To know all of the things before, we need to know what is IoT. That is nothing but Internet of Things. It's like a web connecting all sorts of devices around us that are phone, smart fridge, security cameras, and even industrial machines. So they are all talking to each other, sharing data to make our lives smoother, like adjusting our thermostat automatically or alerting when our groceries are running out. Pretty amazing, right? But here there is a problem. So there are so many different devices connected. It's like having countless doors open on the internet. It is like countless doors open to the internet, each one a potential entry point for the cyber threats. So it is mainly that the problem is cyber threats. So many IoT devices, especially smaller ones, don't have the stronger security because they are designed to be efficient, not secure. And that's where the traditional cybersecurity struggles. So here we have the problem, the traditional cybersecurity measures, here where they struggle with. It is tough to secure such a variety of devices which with different setups and weaknesses. So ensuring security of IoT is essential. We need a solid cybersecurity measures to protect the data these devices send and receive, keeping our information safe, private, and available only to those who should have access. This kind of protection is all about making sure that IoT doesn't just connect our lives but keeps them secure too. So here where intrusion detection systems comes into the play. They are like security guards for the IoT networks. They constantly monitor the system, look for any signs of suspicious or malicious activity, whether it is external hacker trying to break in or an internal device acting out of line. So here the challenge is So here the challenge through is IoT devices generate a huge amount of data, making it hard for IDS, that is intrusion detection system, to spot unusual behavior. It's like trying to find out one needle in a haystack. Now to make jobs easier, feature selection comes into the play. So this process is all about picking out the most important pieces, that is most important information of the data to focus on, cutting down on unnecessary information and improving the system's performance. However, it is not always straightforward. Feature selection can be slow and also computationally heavy, and sometimes it can get stuck, making it hard to find the best features to monitor. This makes securing IoT systems a bit more complicated, but it is crucial for improving the effectiveness of the intrusion detection system. So, in this project, we are taking into the consideration that is intrusion detection systems for IoT networks to the next level by using advanced machine learning and optimization techniques. So, our main aim is to improve how well the system picks out the important features from all the data being generated, which helps the ideas work more accurately. So to do this, in this project, we are using the improved cross search algorithm, that is ICSA, which is great at overcoming problems like getting stuck in the local solutions or poor convergence. So this algorithm, it helps us to identify the most critical features from clean, denoised data that makes the ideas much better at detecting cyber threats in IoT network. So, in short, we are making the system smarter and more efficient at protecting against potential attacks. So, in this system, we are tackling common problem in the machine learning, that is data imbalance, using this modified adaptive synthetic sampling. Let's get into more. So, when one class of the data is much larger than the other class, it can lead to overfitting, making the model less reliable. So, to fix this, we use a technique called modified adaptive synthetic sampling, that is MADASYN technique, which helps balance the data and also improve how well the model generalizes. Once we have selected the important features, we apply ensemble based classifier. So, we apply ensemble based classifier on the feature selected from these datasets. In this project, we are using NSLKDD and UNSW datasets. So from these datasets, we will be selecting important features and then apply the ensemble classifier model. So this approach brings together multiple models to make more accurate predictions, helping the IDS detect attacks more effectively. To make sure the system is performing well, we evaluate using key metrics called accuracy, precision, recall, FN score, false positive, etc. So these metrics gives us a well-rounded view of how well the IDS is securing IoT networks against threats. So moving on as an extension to further improve the performance in this project, we are incorporating stacking classifier, which is an ensemble technique. So this method combines the predictions from multiple individual models to give a more accurate and reliable final prediction, making the intrusion detection system even more robust. On top of that, we have built front-end using Flask framework, which will allow users to test the system and also ensure secure access through user authentication. These additions not only improve the system's accuracy but also make system more user-friendly and practical for the applications. Moving on to implement this project, we have followed the following steps of flow of work. So first, we bring all the necessary Python libraries and packages for data analysis, machine learning, and visualization. And then we analyze two data sets that are UNSW NB15 and NSL-KDD, which contains network traffic data used to train the IDS models. And we clean data by removing duplicates and we handle missing or inconsistent entries. And we do some visualizations that are created to understand the data better, identifying patterns and potential anomalies. And we convert categorical data into numerical labels for easier processing by the machine learning models. And we select the relevant features as X and the target variable as Y for training the model. And then the crow search algorithm is used to identify the most important features from the data set, improving the model's efficiency. To address the data imbalance, we apply the MAD-ASYN technique to create a balanced data set. And we divide the data, that is we split the data into train and test sets. So train set is used to train the models and validation set is used to validate the models. That is, they are how well they're performing on the trained data set. And we choose and build different machine learning models for the intrusion detection system. And then the models are trained on the data set to learn patterns and make predictions. And various evaluation metrics such as accuracy, precision, recall, FN score, and others are used to compare models' performance. And here, graphs are generated to visually compare how different models perform on the metrics. And front end, that is a user interface, is built with the Flask to allow users to interact with the system. It includes registration, login setup using SQLite for database management. So the users, they will be able to input feature values through the front end for the prediction, and the entire data is that is entire input is pre-processed to match the format expected by the trained model. And trained model makes the predictions based on user input. Finally, the predicted result is displayed on the front end for the user. Moving on to the algorithms used, these are the algorithms used in the project. This is the proposed model, and this is the extension model which is used in the project. So, stacking classifier is the extension model. This has performed well in detecting the cyber threats. So, we have used this in the front end to detect the cyber threat. Moving on to the requirements to implement this project, we need basic requirements which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now to execute, we need to open the code folder. So let us open that. So these are the source code files in the code folder of a project. So in this NSLKDD folder, we have the dataset. So these are the dataset related things, get back. Coming to the static folder, this folder consists of files related to CSS, JavaScript, Bootstrap files. And here in the templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have model files. So these are the model files which contain the algorithm information, and this will be loaded into the project code during runtime of the application. Here we have the processed NSL KDD dataset. So we have loaded the dataset from this folder, and here we have the processed NSL KDD dataset. So this is the processed NSL KDD dataset. This is after complete pre-processing. Let's get back. And here in this we have UNSW. So here in this folder we have UNSW source dataset, that is pre-process. After pre-processing, here we have it in this file. And here we have two notebook files. These are the two Jupyter notebook files which contain the algorithm information, and this will be loaded into the project code during runtime. Sorry, this contains combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here in this NSLKDD Jupyter source file, that is a Jupyter notebook file, here we will be having the data set, that is NSLKDD data set is used, and all the models are trained on the NSLKDD to detect the cyber threats. Similarly, in this UNSW NB Jupyter source file, we will be loading this UNSW NB dataset, and then we will be training all the algorithms on this UNSW dataset. And this is the signup.db file. This file is a database file which is used to store the user information. And here in the sample file, we have the test cases that we will be using in the front end to detect the cyber threats. Now let's execute. To execute, copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path, and now click on enter. So this will change current directory to the code folder's path. Now compile app.py file. So give the command python space app.py and now click on enter. This will compile app.py file and it will execute Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. Now we need to copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. Now I prefer Google Chrome, so I will paste it in that. Paste the link, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So register first. Fill in all the details if you are registering newly. I have already registered, so I'll directly log in. Provide your username and the password. Now click on login. So we have logged in successfully and we are redirected to prediction page of the project. As we are going to detect cyber threats on both the datasets that are NSLKDD and UNSW. So first we will be using NSLKDD for intrusion detection. So let's click on this NSLKDD. So here we have some parameters that are need to be entered. Based on the given parameters, we will be getting the prediction whether which type of attack is present. So first let's understand these parameters. First we have is duration. It is the total time of connection measured in seconds. Next one is protocol type. This is the type of protocol used for communication such as TCP, UDP, and ICMP. Coming to flag, this is the status of connection indicating whether it's normal established or it has errors. Coming to SRC bytes, it is the source bytes that are the number of bytes sent from the source, that is attacker or the user. Coming to destination bytes, these are the number of bytes sent to the destination, that is server or the system. Coming to LAN, it is a flag indicating if the source and the destination IP addresses are the same, often used to identify specific type of attacks. Coming to hot, it is whether the connection was labeled as hot, indicating suspicious or anomalous activity. Coming to number of failed logins, this is the count of failed login attempts during the session, which may suggest a brute force attack. Coming to logged in, it is whether the user was successfully logged in or not. Coming to SU attempt, it is the number of attempts, that is super user access, that is root was attempted. Coming to numRoot, it is the number of successful attempts to gain root, that is the administrator access. Coming to number of outbound CMDs, it is the number of commands sent from the system to external host, which may indicate suspicious behavior. In host login, it is whether the login is coming from a host or not. Coming to in-guest login, it is whether the login is a guest login or a non-guest login. Coming to service count, it is the number of services that destination service providers. Coming to SRV, error rate, it is the rate of the service errors encountered during the communication, which may highlight system issues or attacks. Coming to SRV error rate, it is the rate of service related errors such as server failures. Coming to different SRV rate, it is the difference in the service access rate used to measure changes in the server activity. Coming to SRV different host rate, it is the rate of access attempts from different hosts to the same service, potentially indicating a coordinated attack. Coming to destination host SRV count, it is the number of services available at the destination host, indicating systems complexity. Coming to destination host, different SRV rate, it is the difference in the service request rate from different host to the same destination. Coming to destination host service, that is SRV different host rate. So it is the different in the service request rate from different host to the same destination. Coming to destination host, SRV different host rate, it is the rate of the service request from the different host to the same destination service, helping to identify potential intrusion patterns. So as of now, we have understood all these parameters. Let us enter them. For that, let's open sample file. So this is in this we have the test cases. Let us open it. So here we have the filter. Let's remove it. So these are the test cases using which we will be detecting the cyber threats, that is the intrusion attacks. Let's enter them. We have opened the test case of UNS NBW dataset. Let us open this. So these are the test cases that we will be using to detect the cyber threats. Here we have total 5 classes. So let us apply the filter. Let's check with the class 0 and see whether it will correctly predict it or not. So here, let's try with this test case. So duration value is 0. Protocol type is also 0. Flag value is 9. SRC bytes are 520. Destination bytes are 0. Land value is 0. Hot value is 0. So next we have is number of failed logins, that is also 0. Logged in value is 0. SU attempts is 0. Numroot is 0. Number of outbound CMDs are 0. In-host login is 0. In-guest login is 0. SRV count is 446. SRV error rate is 0. SRV error rate is also 0. Different SRV host is 0. And this one is also 0. Destination host SRV count is 194. Destination host different SRV is 0. And the next values we have is all zeros. Let us click on predict. So here we got the prediction that attack is detected and that attack type is DDoS. It means that there is attack in it and that attack is DDoS attack. Let's try with one more set of input. Sorry, we have closed it. Let's copy the link again. We need to sign up as we have closed the application. So we are doing with NSLKDD dataset prediction. So now we will try with the other class. So let's check with the first class. So we have only one here. where duration is 0, protocol type is 1, flag is 3, SRC bytes are 0, destination bytes are 0, land is 0, hot is 0, and number of failed logins are also 0. Login value is 0, SU attempted is 0, num root is 0, number of outbounded CMD is 0, in-host login is 0, in-guest is 0, SRV count is 1, SRV's error rate is 0, SRV error rate is 1, different SRV value. Let's copy it and paste it. 0, 1. Let's copy it, paste that here. 0. And the other one is also 0. Click on predict. So here we got the prediction that there is no attack detected and it is normal. It means that there is no attack in the data. Let's try with one more test case. Now let's try with the second class. So where duration is, let's try with this one, where duration is 32, protocol type is 1, flag is 9, SRC bytes are 1217, destination bytes are 124, land is 0, hot is 0, number of failed logins are 0, login is also 0, SU attempt is 0, num root is 0, num outbounds are 0, in host login is 0, in guest is 0, SRV count is 1, SRV error rate is 0, SRV error rate is also 0, different SRV rate, where do we have that? Yeah, here we have. So it is 0. SRV different host rate is 0. Destination host SRV rate is 10. And destination host different SRV is 0. Destination host, so let's copy this last two values because they are decimal points. Paste it. Now click on predict. And here we got the prediction there is attack and that attack is prob. It's a prob attack. Let's try with one more test case. Let's try with this third class. So here I have given all the inputs. Let's click on predict. And here we got the prediction as R12 attack is detected. Let's try using one more test case. So here I have entered all the given inputs. Let's click on predict. So here we got the prediction that U2R attack is detected. So here we have detected all the different 5 type of attacks, that is prob, U2R, R2L, and that is not, and there is no attack. Let's try with the other data set, that is UNSW. Click on that. So let's understand these inputs. Here we have SPKTS. It is the number of packets sent from the source during the session. Coming to DPKTS, it is the number of packets sent to the destination during the session. Coming to DP bytes, they are the number of bytes received by the destination from the source. Coming to STLL, it is the time to live, that is value of packets sent from the source, which can indicate how far the packets have traveled in the network. Next we have is DTLL. So it is the value of packets sent to the destination indicating how far the packets have traveled. Coming to DINPKT, it is the number of packets received from the destination host in a given time frame. Coming to SWIN, it is the size of the source window, that is the buffer space in the TCP connection, indicating how much data the sender willing to receive. Coming to STCB, it is the total number of bytes sent by the source in the TCP connection. Here we have DTCPB. It is the total number of bytes received by the destination in a TCP connection. Coming to TCP RTT, it is the round trip time for a TCP connection, which measures the time it takes for a data to travel from source to destination back. Coming to ACK-DAT, it is the acknowledgement data indicating packets that have been acknowledged in a TCP connection. Here we have S-mean. It is the mean average size of the packet sent from the source. Coming to trans depth, it is the depth of or travel of the transaction in the network, which helps to measure the complexity of the interactions. The next one we have is CTSRV SRC. It is the number of distinct service provided by the source during the session. Coming to CTDST SRT LTM, it is the total number of connections made from the source to the destination over time. Coming to ISFTP login, it is whether a login attempt was made through FTP service, that is true or false. Coming to CTSRV destination, it is the number of distinct service accessed by the destination during the session. So we have understood all of them. Let's enter them. Open the UNSW. So here we just have two classes where there is attack or not. So let's try with the first test case. So let's try with this test case. So SPKTS is 2. The next value is DPKTS is 0. DB bytes is 0. STLL is 254. DTLL is 0. DNPKT is 0. Next we have from SWIN to ACKDT is 0. So let's enter zeros there. Here we have SMIN value as 100. Next we have transaction depth, that is 0. CTSRV is 4. CTDST is 4. ISFTP is 0. CTSRV is 4. Click on predict. So here we got the prediction that attack is detected and the attack type is DOS, backdoor. It may be Cummins or recon traffic. So these are the different traffic types, that is attack types. It may be either of them. Let's try with one more test case. Let's try with the third test case. So this is the third test case where SPKTS is 44, DBKTS is 46, DB bytes are 24004, SCTL is 31, DTL is 29, DNPKT is this one. Let's copy it. SWIN value is 255. STCBP, let's copy it. Copy the next value. TCPRAT, ACKDT, SMean. Next value we have is 0. So here we have total 8, 1, 0, and 5. Now click on predict. So the input will be processed at the backend and then we will be getting the prediction. And here we got that there is no attack detected and the data is completely normal. So there is no attack. Let's check with the graphs. So click on graph. So here we have graph for the NSL KDD dataset first. So this is the sample outcome graph. Here on x-axis, we have total different attack types and on y-axis, we have the count. So these are the total different attack types. Here, if you observe these R2L prob U2R here, if you observe these three classes are less, right? So that is why we have implemented the class imbalance technique. So to overcome this class imbalance, we have implemented MTSAYN technique. And here we have the correlation graph, correlation matrix. This shows the correlation between the variables. And this is the accuracy comparison graph. Here on x-axis, we have all the algorithm names, and on y-axis, we have the all. Here on x-axis, we have accuracy, and on y-axis, we have algorithms. This is the precision, recall, FN score comparison graphs. Here we have ROCOC, and here we have UNSW sample outcome graph. So here on x-axis, we have the class tables and on y-axis, we have the count of that particular class. 0 refers to no attack and 1 refers to attack. This is the correlation matrix we have. Here we have accuracy, precision, recall, and FN score. Here we have ROC, AUC score graph. Now let's click on logout. In this way, just by giving parameters to the system, that is the application, the algorithms, ensemble method that we have used, it will give the prediction, that is whether there is attack or not. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.